Good morning, good afternoon and good evening. Welcome to today's BIM REC webinar 18.0. BIM Level 2 and beyond. Discover the benefits of working with shared structured asset information. What are you going to take away from today's session? Well, during today's session you're going to get a very informative overview of BIM to help you and your team start thinking really strategically. You're going to learn, is lean construction necessarily mean construction? Are lean manufacturing techniques compatible with collaboration? You're going to discover how and why to love COBie and HNS. You're also going to learn how BIM Level 2 will evolve into Level 3. Today's session is really going to benefit you because Nick is going to help you understand BIM as a leaner, testable and more efficient way of working for buildings, for infrastructure and for environmental management. This webinar will clarify the role of contracts and the role of collaboration. Nick will be discussing COBie and the HNS file as first steps and how these will really help start the journey towards Level 3. Today's session is going to last between 50 to 65 minutes long. It's going to be split into two sections. There'll be the presentation followed by a quick 5-10 minute Q&A towards the end of the session. I will be hosting along with Nick. As always, we do have a ton to get through, so we're going to move quickly throughout the presentation and take questions towards the end. For those of you who have sent questions in prior to the webinar itself, Nick has tried to cover all of these questions within the actual presentation. However, please do stay to the end to ask any questions which haven't been covered already. For everyone live on today's session, at the very end, once this webinar has closed, there will be a pop-up box. A pop-up box will appear. Within that pop-up box is going to be slides for today's webinar. You're going to have all of Nick's contact details, a link to our next webinar, and my contact details as well. Now I do see we have quite a few people regulars turn up for these sessions, which is fantastic. Hello everyone. It's great to receive the positive feedback you guys have been sending me via email or what we've been discussing over the phone. It's great to receive the feedback. Please do keep it coming in. I will continue to pass the thanks across to the speakers at these events. So yeah, once again, thank you. For those of you new to the BIM REC webinar series, and for those of you who don't know me, my name is Barry Hassib. I am the Managing Director of BIM REC and AEC Recruitment. BIM REC are a real essential recruitment partner for individuals and organisations really looking to win with BIM. We're really passionate and devoted to help our candidates, clients and the industry really overcome any obstacles throughout your entire BIM journey, whether that's helping you as an individual find your next ideal opportunity, or whether that's helping your team recruit and retain anything from fresh graduates through to leading BIM directors across the globe as well. For those of you new to the BIM REC webinar series, we're often asked, why do we do this? Well, the reason why I put this series together is because whilst continually surveying candidates, clients and the marketplace as a whole, we really discovered the industry still has a really long way to go with regards to BIM. So I thought, what better way to help educate than bring BIM leaders like we have today directly to your desk. As many of you know, BIM is a journey. Some companies and individuals have had great success stories, whilst for others it's been a real steep learning curve, or further still, people are still yet to embark on their journey within BIM. So whatever level you're at currently, our goal is to really just simply help you win with BIM, helping ensure our candidates, clients and the marketplace in its entirety have access to world-class leaders who are real strong experts within their field. I'm very proud and privileged to announce we have Nick Nisbet with us today. Nick is one of the most internationally recognised experts within BIM. He is the owner and director of AEC3. He's a technical coordinator at BuildingSMART, and he's also an advisor to the UK Government BIM Task Group. Nick has specialised, you'll have to bear with me the way I say this, Nick has specialised in the support of planning and construction processes by integrated model-based IT solutions. For us guys, that's known as BIM. I say it that way as Nick has been involved in this thing called BIM since 1977, so brings a wealth of his knowledge and expertise within this field. Nick is presenting today on BIM Level 2 and beyond. Discover the benefits of working with shared structured asset information. With that said, I would now like to pass you over to Nick.
Okay, thanks for attending. I've got 7 topics to cover and not a lot of time. I'm going to frighten some of you by saying the first 3 are about theory, because I've given myself a very clumsy title, working with shared structured asset information, and it needs a bit of explanation, I think, to decide what is the justification for BIM, and I think that's the title for the first half of the session, and then the second half we'll look at some ideas in practice, examples of value, level 2, COBie and health and safety, and then the road from BIM level 2. Now I apologise for using the UK jargon. Some of you overseas may find a little UK focus to certainly the second half, but perhaps in the questions and answers at the end we'll pick up anything that is left unexplained on the way through. Okay, just get my controls working. There we go, right. Okay, so 3 sections on theory and then 4 sections on practice, and hopefully at the end of it we'll have some idea of what the justification for BIM is. I'm taking as my starting point level 2 in the UK. Many of you will know that level 2 is the UK central government mandate for their spending departments, that by April next year they must all be able to do level 2. Now, doing level 2 as a client may be different to doing level 2 as for people on the design side or the supply side generally, or the construction side. But that basic vision has inspired a lot of work in the UK, a lot of discussion, a lot of anxiety, and I think many people set out on that journey without stopping to pick up a map. And to pick up on Barry's comments at the beginning, I'm going to try and give you a little bit of a map which will allow you to judge BIM in practice against 3 basic criteria. So the first one is the idea of data, not documents, and it's the one that's most challenging for the construction industry. It's why would anyone get involved with sharing structured information instead of documents? Well, the short answer is probably that every other industry has done this in some form or other already. And some of the reasons why not that are advanced to the construction sector or really don't hold water. The fact that we're highly fragmented, that we're highly agile, that we're highly this, that and the other, are all excuses that could be levelled at the retail sector, and yet certainly in the UK retail is almost entirely paperless, both from the customer side and from the supply side. So there's a general trend for getting into information technology. Why on earth would you do that? Well, in essence, the idea behind IT is in 2 parts really. One's about communications, which we'll talk about a bit later, and the other is about taking one input and actually making it work hard for you. And that's an idea that applies to BIM authors, it applies to cost estimating tools, it applies to ordering and ERP processes and so on and so forth. That one input should generate for you many outputs, and it may even enable new applications and new methods of working to be allowed. That one input can also be subject to many different checks, both manual checks presenting the information back at people in different ways, in a way that they find familiar. The classic example is 4D simulation. Everyone says they understand the project schedule, but when you offer them a simulation, it's then when the conversation between experts and customers and so on really gets animated, because they finally understand how the construction process is going to impact them. Checks can be anything through to, is that a reasonable value, all the way up to automatic checking, and that can become highly sophisticated. Once you have that checking in place, suddenly you have the opportunity of designing your workflows, and that's where the collaboration and contractual relationships come in. If you can redesign your workflows, you have chances to eliminate redundant tasks, you can do more tasks in parallel, you can actually optimize your processes in a way that makes business sense. The example that I heard about last month was a firm of designers working for a housing developer, and they were going for planning permission, building regs permission, and letting or tendering the groundworks contracts on the same day, because they were confident that all three processes would come good and converge, so they would get an earlier start on site. Something you wouldn't begin to do in a document-driven process, where you would call that overcommitting. So it's a pyramid, really. At the bottom, or an arrow, at the bottom we've got to think about information, we've got to think about reusing that information, one input, many outputs, making sure that it's available to the right people in a form they can use, and so on. Once you have that, you then get into the management of that information, because you structure it, which renders it checkable, so that one input can give you many checks. Those checks can be of varying degrees of sophistication. And once you've got the confidence that it is checkable, you can then move into the world of sharing, strategic interoperability, many paths for the data. I think we'll come back to the pressures for many paths a bit later. So to go over it again, information, basic BIM, you might have plans, but at the same time you're getting your 3D, you're getting your schedules, you're getting your sections, you may get other documents out of it. That doesn't have to be in 3D. The reuse of specification information is a good example where by inputting it once, you can actually structure the cost estimating and the specification and the procurement processes. So the structuring, I've said it's about, the reason for structuring the information is to make it checkable. Checking applications are typically separate from the authoring application and the sharing applications. The illustration here is the Singapore E-Plan check system, probably 12 years old now, but basically in Singapore you were able to submit your building model for building and zoning control permission, and you get an answer within 30 minutes. Not only that, but you could actually test your building as many times before that, before making your submission. It was only the actual submission that cost money, because obviously you needed a printed certificate. and so on. So that's probably at the high end of the checkability range, but it was feasible then and it remains feasible now. Okay, and then we get into the sharing. Applying strategy, using interoperability, letting the data exist outside of any particular application, outside of any organization perhaps. That kind of sharing starts with yourself. What do I mean by sharing information with yourself? Reusing it. Much of the industry tasks and workloads at the moment are not reusable. If you have you rarely are able to go back and reuse work that you've done on a previous job. Start sharing with your colleagues, and then you have your project partners perhaps, and of course clients. Clients will feature quite heavily in later discussions here, and then with regulators. So there's many directions of sharing the information. And as we move from level 2, it'll become more and more frequent. It'll become not just occasional, it will become more and more continuous, or whatever. So that sharing is the real challenge of the BIM journey. Okay, that sharing and looking again at our processes may mean taking a close look at some of the things that we take as being everyday normal practice. This particular diagram shows 4 processes in a cycle. Starting in the top left, the client's requirements come down through various layers in the industry, down to someone who's actually capable of doing design. The requirements will exist in one form. The designers, engineers, planners will develop schemes and proposals, maybe using BIM authoring tools. And then those ideas will then go back up through the management chain seeking approvals. If it gets all the approvals necessary, the information then becomes available to the client to use. Equally, if there are disapprovals or issues raised, then they become across and then are filtered back down through the management structure of the project for design enhancements. So this typically, I mean, and I've certainly seen in large organizations, the actual flow diagram represented here can fill an A1 sheet of delegation and things, but this is the essential process. Some of the layers that the requirements go down through and the approvals come up through will cross between companies, it'll cross between disciplines, disciplines will be merged, companies will take a common view until eventually the client and the client's advisors give their endorsement, perhaps. What I think is interesting here is that the focus of BIM has been very much on the design development or the engineering development or whatever it happens to be, and yet we haven't paid much attention to the representation of the client's requirements or even the technical requirements, and we haven't paid that much attention to tracking the approvals as we go back up. So I think a complete level 3 system will have to look at all 4 of those and how they work together, and how the requirements are actually the pull on the industry, rather than sitting down and saying I'm going to produce an architectural general arrangement drawing. Maybe we should sit down and say, what is it that the people dependent on me in the information chain actually need? Can I release that information to them early so that they can start their job and we can get more concurrency going? And rather than relying on the stereotypes of what kind of documents have to be produced, we actually get down to the detail of saying what information is required and when, and break the habit of postponing information delivery to the last minute and then relying on the fact that the receiver won't be able to check it for some time. So this is a prescription for a lean method that, that the information is pulled by requirements and is approved and signed off with a minimum amount of wastage. Okay. This is actually the same diagram again, showing in this case 4 levels of management. At the top we have client, at the bottom we have a design engineer, and the requirements and tasks flow down the left-hand side of the diagram, and completed designs are passed back up the right-hand side for increasing acceptability. And what this kind of diagram offers is the chance to actually make it into a managed process. So unlike the previous diagram, which was very abstract, we have the chance here to actually make the process of virtual design very systematic and robust. And in fact, it wouldn't matter if you introduce more layers of management or technical skill or strategic skill, whatever it happens to be, into it, the diagram would actually stay much the same. Okay, so the reason for getting into data: reuse of the information, making it checkable, and then designing processes for automation and repeatability and efficiency. The second justification for BIM is actually to actually look inside what a BIM model is and discover that it's not that a building or an engineering structure or an environment management structure isn't just a pile of parts. It is actually more than that. It's about a large number of objects that we put into the model. It's also about their attributes, but most of all it's about their relationships. That actually, yes, if it was just about the shape of the objects, we could all use SketchUp or Rhino and produce and consider we've done the job. But actually, we need discrete objects, we need definite attributes, and we need to know what the relationships between them are. Okay, so to be a competent organization, you have to be able to manage those 3 things: objects, attributes, and relationships. What else do we need to be a competent organization? Well, many of us are focused on the middle of these 3 steps that I've got on the diagram here, that we have the BIM authoring tools. We try and use them. But actually, a competent organization has to declare that they're ready to receive structured information instead of documents and emails. In other words, we have to be open to upgrading our checking of the incoming information. Then we learn to process and generate and merge structured information to actually get the outcomes where our competencies allow us to do. And then finally we need to offer to supply structured information instead of documents and emails. In other words, yes, in an era of transition, we may have a situation where we end up offering to say, well, we can give you the plots or the drawings or whatever it is, but if you like, we can actually share the BIM information with you. And then that lets other organizations develop their BIM capability in not necessarily all in one big jump at the same time. So there are 3 elements to being a competent organization. That structured information has got to include objects, it's got to include attributes, and hopefully some relationships between them. I won't go too far into the detail, but just taking the example of a door, the attributes of a door are many and varied. We have its basic identification. We may have a few basic attributes like a name and a description. It may have constituents. It may have properties of various complexity. It may have shape in 3D, and it may have service life or other time-based attributes. It can be quantified in some way, both in terms of physical measurement and maybe functional measures. What is the maximum flow rate of people through this door or whatever. I think that's probably the basic functional measure of a door. And there may be applied values associated with that door, cost values, environmental values, and potentially social impacts or whatever. But so even a single object like a door has a multitude of different properties and aspects associated to it. And BIM has got to help us manage those, not necessarily insist that all the information is present all the time, but to allow for the fact that that may be the sum total of the information we're dealing with. More complexity comes to think when actually we think of that door in the context of a whole building, and suddenly the relationships it has become much more interesting. First of all, that door will have a relationship with the two spaces that it's either side of. It will have a relationship with the wall that it's in. And so here we have the space and how it might break down or be aggregated upwards back into the whole building. It may be part of a system, which might be the internal divisions of the building or whatever. It will have a relationship to a style or a specification or a type or a product, and it may have relationship into a classification, a cost schedule, and it will have a relationship in terms of positioning. Of course, ultimately it is somewhere X, Y, Z in space, but it may be relative or absolute to other things. So there's a lot of relationships that actually make that door meaningful. And these are the things that we have to accumulate in order to have a good, testable, robust design or proposal as we go through. So objects, attributes and relationships are the key things. There are tools that consider a very small subset of the whole facility, and they make focus purely on the objects. An ordering system, an ERP system, may be entirely focused on the objects and the attributes with no interest in its relationships and so on. On the other hand, analysis programs are impossible to use unless the relationships between the objects are actually available. So, okay. And just as a clue, and I will be talking about the IFC on and off during this, it's that basic idea about how you represent assets is reflected in the IFC model, that from its root, you can see there, it immediately divides the world up into objects, property definitions and relationships. And so the reality we need to model is very closely reflected in the IFC model. Furthermore, okay, but what are the things that we actually need to manage through BIM? I'm going to argue very quickly that there are three kinds of things that we need to think about. There's the physical stuff we can kick. There's the spatial stuff, spaces and stories or addresses of things, which is about how human beings think of the building or the piece of infrastructure or whatever it is, and how we use it to a large extent. And there are processes that we associate with those to construct them, well, to order them, to construct them, to maintain them, to repair them, whatever it happens to be. And actually what makes the real challenge for BIM is to find out how we're going to manage those three things during the design development, and then during construction, and then during the operation of the facility. Again, some systems are entirely focused on the physical. Some applications are entirely focused on the physical side of things. Some facility management processes attempt to treat the building as a pile of parts. In other cases, such as project planning, the emphasis is very heavily not so much on the other two. But actually, the real benefits of BIM come from considering all three. And let's not dwell on that. So here are, and this is a diagram that could probably be the subject of a talk in its own right. Here are the things that we deal with and need to deal with in the world of BIM. On the left-hand side, we have the spatial structure, the addressing, the way that humans use and think about facilities. At the lowest level, we have a space or a location, and they tend to be grouped into floors or stories or regions, and taken together they make up the whole site. And a building may contain 10, 100, 1,000 spaces, so it's very important to divide them up and make them manageable. We make them manageable with these regions. We also use zones, maybe occupancy zones, circulation zones such as public space, escorted space, private space, many different ways of zoning up the spaces to make them manageable. In the middle we have the physical reality. At the lowest level we have the idea of a component, some part of the building, and again, to make that manageable, we group them by type or specification or product. In some cases it's very obviously a product, has wash hand basins or whatever. In some cases it's a type such as a material or generic substance or whatever. Taken together, that makes up the whole facility, but we also divide them up into systems, what quantity surveyors might call the elemental breakdown. We group components by the reason that they're in the building, and so on. And again, this is a way of rendering the project manageable, or the facility manageable, and it's partly the way things are designed. And so on the third side, we have the idea of a project, fairly general idea, made up of specific jobs or tasks or whatever. And again, we group them with common specifications, and we group them into work packages. Now that triple nature of the facility of BIM is actually what makes it more complex than mechanical engineering tool or mechanical engineering tasks or automotive or whatever, because it is actually the three different aspects of the facility being organized, managed and brought together to work together that actually represents the challenge for the industry and what BIM has got to answer. I fully appreciate that the middle bit, the physical stuff, is the main focus during the production stage in many projects. The spatial structure is decided or adopted from the geography fairly early on, and tends to stay fairly constant. And at the end of the project, there's more and more focus on identifying what the jobs are and how they can best be specified and organized. So there is a time element to this diagram. There is also a parallel processing of these three things. Okay, won't hang longer. Just to give a quick overview of what the IFC can represent, this is a fairly random collection of things, but I wanted to emphasize that we can represent many kinds of shape, most kinds of building element and HVAC element. I go so far as to say all and wait to be challenged. We can represent the zones and compartments and the spatial structure, and we can represent more complex relationships between things like holes and voids cut into the structure for reasons, and different views of the same object. Structural analysis can exist in the same model as the structural elements. A few more things. I've mentioned systems as being particularly important. I would argue that even the envelope of the building and the foundations are discrete systems which need to be named and coordinated. And then there are some abstract things here that we can represent. Constraints, rules, requirements, impacts, the relationship between physical controls and the signaling between them. Yes, it can represent grids and drafting, and we've recently added the center lines for roads and railways, whose name escapes me right now, but as a special kind of grid, and so on. So there's a lot going on there, and getting even more vague, we can support that with actors, work plans and schedules I've already mentioned. External data, we can link the IFC model to external data. As we moved into the semantic web, which probably is level 3, the linking of data sets will become more and more important. Classification and documents can be associated into the items. We can document the relationships we call connectivity, which parts are joined to which and how it's done. And we're moving into the ability to represent more and more aspects of the geographical context and civil elements and so on. So a lot of the needs of BIM as we get more and more capable in using it are already represented in the IFC. Just to go back to the relationships, there are two kinds of relationship which are universal. There's the idea of definition, when you say A is a kind of B, and decomposition, when you say A is a part of B. Two different things, often confused when people try and condense data sets too much. But IFC also offers other kinds of relationships like connection and association and assignment. So we can actually represent most of the relationships that are needed to validate or to represent and validate a design. Okay, so that was the theory section, bit of a rush. First theory, data not documents. Second theory, that we need to base what we're doing on assets. That's an idea that's fairly familiar in the architectural building sector. It's more of a challenge for in infrastructure, where a lot of design work is done in terms of maps and boundaries and edges and so on. But in the end, the client is acquiring assets of one kind or another, and the industry needs to make sure that at every stage they are able to represent the client's view of what's being delivered. And the third thing is the triple nature of the built environment. It's about physical stuff, but it's also about the spatial addressing of things, and it's about the processes that actually make them viable. Okay, now I'm going to move in to a little bit about practice. Some examples of value. I've already mentioned the Singapore e-plan checking. Now, I can't actually query the audience to find out, but the idea of getting technical building consent, zoning consent, maybe even some aspects of planning consent in 30 minutes, I think is achievable because I've seen it work. I helped develop the Singapore system. And I think it's a desirable goal in the sense that it changes the dynamics of the process. It means that responding to the client's needs is a continuous process and doesn't have the hiatus of waiting for 1 month, 2 months, 3 months, 4 months for some kind of bureaucratic process to take place. It actually has a radical effect on the economics of things. I was involved with a project in the US where someone was developing a ski resort. in a fairly remote area of Colorado. It turned out that for the local county to assess the proposals for that scheme, it was going to take them 3 years. It wasn't their fault because they were a small county, a small district. They never had much demand on their services and so on. And so all sorts of strategies come into play, but the basic reality was that the client desperately needed to know which would be the first season he was going to be able to open for. And that's a tragedy in the sense that it actually puts into question the viability of a scheme which was at least plausible. So automatic building regulation is a clear win in the value arena. It just eliminates risk and uncertainty from the process. Other examples of achieving value, I would point to Norway, where a number of pilots have been carried out of integrated BIM using BIM servers. This is Tromsø College, a small extension building, which was used to prove the viability of the BIM model. In the UK we had the Avanti program, which did a similar exercise and produced measured results. So in both cases you can get the reports, find out what the final assessments were, and the wins and losses. But bear in mind, Tromsø College was done in 2005. So, and the Avanti program was 2005. I think you'd have to go to the Constructing Excellence site to get the Avanti case studies. Okay, another example of gaining real value was ISIM, Integrated Carbon Information Model. The ability to go online and assess your scheme for its carbon content, to exchange specifications, to update Revit from that by using IFC exchanges, and indeed to update the NBS Create specification documents. So what we have going here is, in this case, a very simple model, but by swapping out the specification of a slab, we can actually track the change in embedded carbon. And in the bottom left-hand corner you can see that as the design has evolved through 7 or 8 cycles, the range of uncertainty of the carbon content has been reduced, and in general the expected outcome has got better. So it probably doesn't matter whether it's carbon or whether it's cost or whether it's energy use or whatever. The value is in the power of being able to assess and improve on a continuous basis. Okay, won't go too much into that. Equally, this is a very simple clause from a US Army contract. Failure of the contractor to provide an approved COBie information exchange dataset will result in $5,000 retainage held for contractor until the dataset is approved. That's $5,000 a day, by the way. Now, is that an example of value? Well, it's an example of setting up clear contractual relationships for the demand and supply of information, which allows the industry to actually improve its processes and work confidently, and so on. So I'd actually hold that up as a positive thing. And last of all, the pilot project for the UK government BIM strategy, Cookham Wood, number of buildings, and again you can go to the Cabinet Office, the UK Government Cabinet Office website, and you can download the metrics that explain the savings that were achieved by introducing a clear COBie deliverable from the design process, from the tendering process, and from the handover process, and the ramifications of that ask. Again, you can achieve those. You can obtain those. Some very nice models, of course. More importantly, we have an end user. For the first time, I could understand a building design. It allowed me to contribute and comment both positively and negatively for the first time, rather than just having to look at flat drawings. Better for less. Improved visibility, reduced risk, improved efficiency and certainty of outcomes. And the numbers are indicating around 17, 18, 19, 20% savings. Now, that is enough to have got the endorsement and the attention and the continued engagement of the government. I know it's always hard to find examples of proof that BIM works. The other way of looking at it is to look at examples where people tried BIM and walked away. And usually, I'm not saying it doesn't happen, but it usually is because they say we'll do BIM in parallel with the 2D system or the conventional document-driven system, and by under-resourcing the BIM they set it up for failure. I know one large organization in London had a project like that, abandoned BIM halfway through the project. However, the participants turned around and said that they would never work on a document-driven project again. So even out of failure grew a success. I think the other metrics that have been given to me informally is simply that BIM, even lonely BIM, is saving 50% of the production costs for an organization. Now, on the platform of that, you then have some resources to invest in actually doing collaborative BIM and going to the next level, where the order of magnitude of the savings and benefits becomes 10 times bigger, because it's about a better building, not just a better production process. Okay. A few words about the level 2 method. Let's just say that that's not what I wanted. That level 2 BIM is a minimum standard. Now, it's a minimum standard for people dealing directly with the government, and it's a minimum standard in the sense that it is moving into BIM to the minimum amount necessary to get some benefit. So maybe the step from documents to data has been made as short and as reassuring as possible, but it's not the end of the story. How so? Because essentially the only reason what BIM is really, level 2 BIM is asking for is that data should be in a shareable form and brought together through a CDE so that it can be operated on collectively, whether for analysis, clash detection, gap detection, or whatever, but most importantly for the production of COBie. In other words, making sure that the client gets a clear, unified view of his scheme in terms that he can use. So I won't go into the ideas behind the CDE and the collaborative working, because I think they've been adequately covered by other speakers. But I think the basic idea to make a clear distinction between work in progress and then a process, the light blue boxes, a checking process so that when it's shared people can rely on it to the degree of the status that it's been given to it. And again, moving from shared and reviewable into published, again making sure there is a clear and definite decision to move a document to that point. Okay, so level 2 in short, keywords, it is lean in the sense that the client is asking for information and is helping to organize the supply chain to pull information towards the client. It's client orientated in the sense that it's the deliverables are primarily for the client and really don't necessarily interfere with the relationships between the consultants or the relationship between the contractor and the subcontractors. And it's starting to get an emphasis on TOTEX, total expenditure, by saying that there can be a common view or common basis for assessing the capital expenditure and the running cost expenditure. And essentially it's driven by a license to underlay other people's information underneath what you're doing, to compare and clash, report and comment. Very simple model, and that's why I say it's a minimum standard. I'm just going to say a few words about COBie and health and safety and CDM 2015. These are specifically UK issues. Why have I put them together? Well, let's ask the question, why does the owner want data anyway? And this is a list based on the BSI PAS 55, which is now ISO 55000. Asset registration is the first one. I won't go through them all. There are many reasons for wanting the data. And at the bottom we have regulation and compliance. And what makes that interesting is that the first 9 uses for the data are really built around COBie, about a deliverable in a structured form that the client can use to take possession and operate his facility. In the US Army, the key message was, can we practice operating the facility for 3 months before the final handover by using the information delivered in a COBie. I've just noticed a slightly distracting question in the side here. Let's just see. ISIM stands for Interoperable Carbon Information Model. Okay, the last one, the health and safety, is perhaps the best model we have in the UK for saying it must be possible to do BIM. Because we have regulations and legislation that says that information must be passed from the designers, well, from the owner of the site initially, but from the designers to the contractor and from the contractor to the owner. So we already have a very clear example where structured information relating to the potential health and safety of the contractors, the builders, the subcontractors, and to the occupiers must flow. And so actually COBie is just an extension of that idea by saying actually there is information which, whilst not legally obligated, is of such importance to the effective use of the asset that certainly the government and large property owners are engaging in saying that it's required. And I think the analogy is very powerful. That a risk register, and this is taken from a road project up near Manchester, or near Liverpool I should say. Okay, structured information. Now here they're actually relating it to standard severity and likelihood rating. They're linking it to actual places on the site. They're linking it to data sets which give more information about the information, and diagrams in 2D and 3D. So the idea of the hazard register being a dynamic document that is maintained throughout the project, and of course it can be filtered and prioritized because it's not necessary to document normal risks or whatever. What we're trying to do is to document specific risks and exceptional risks. And in the end you end up with a scorecard where the various aspects of the risk can be assessed, and those outstanding risks, those prominent sore thumb risks, can be hammered back down, to mix the metaphor. Okay, right, I won't linger on that. COBie, equally, is an invitation to structure the information in a way that makes sure it's usable not just by the author but by the recipient. It's a collaborative effort between designers, the supply chain, the contractor, and it's progressive in that it builds up and hopefully builds down risks. It builds up to represent the information that the owner needs to operate his facility, but can inform his early stage assessments at the end of detailed design and during tendering and contractors' proposals. So although COBie primarily is focused on CIC stage 6, you can see it has a value at the project initiation stage to pick up information that the client may already have, and then to make sure that the design and construction development is actually keeping the facility on track from the client's point of view. Those of you in the UK will know that there is a standard for the UK use of COBie, which basically says, and I think this is an important idea, that the content of the COBie is bound by the employer's information requirements and the digital plan of work, and should be informed by, or should be grouped by Uniclass 2015. So we have the rules. So practical stuff. Is there enough practical stuff out there? I think there's as much as there's ever going to be in terms of examples. I'll take some, may say a bit more about that a bit later. Now I'm going to say, where does level 2 lead on from here? First of all, there is a strategy for 2025 that by then the industry expects to lower costs by 33%. Although this document was published by the government, it was authored by industry. 33% lower costs, 50% faster delivery, 50% lower emissions, and a considerable improvement in the exports of skills and products around the construction industry. Now, on the right-hand side, we've got some ideas about how that's going to be achieved, but essentially, business as usual will not deliver those kinds of improvements. It has to be based on an efficient, information-driven industry with the maximum amount of automation in the design, construction, and use of the facility, because otherwise those numbers will never be achieved. So from those, you can say, well, actually, we need to start using BIM and GIS information, and we'll be needing to use real-time to get the operational benefits, so we will be getting into big data. We will need process management and automation. The kinds of design flows I showed you earlier, or information management flows, do not make sense if one of the parties says, I'm going to print this lot out and take it home and use a red pen over the weekend or for the next week, and then someone can scan back my scribblings back into the system. It needs to be a managed process without these kind of breaks that some senior managers introduce rather than engaging with the tools that are available. And we will need analytic dashboards like the ISIM example, so that everyone can see the trends that are happening. And as the one of the characteristics of level 2 is that I would guess that most people update the CDE on a fortnightly or weekly basis. One of the characteristics of level 3 will be that cycle time will no longer be acceptable, that actually to converge on a solution, things will update, not necessarily instantaneously or continuously, but certainly on a daily basis. And so people will need dashboards and visualization to actually be able to track the process as it proceeds. To do those things, we're going to need the IFC classes, because that's only the IFC can bring together BIM and GIS information and link with big data. We will need information delivery manual, digital plans of work, and model view definitions to make more and more of the testing at least automatable. Still complemented by visual checking, I'm sure, or human checking, but process automation will need clear process diagrams. And lastly, to actually get the dashboards and the visualization, we will need a common industry dictionary. And just to highlight that those are the three standards that the BuildingSMART organization is delivering and offering to the industry. We call them IFC, IFD, and variously IDM, MVDs, or digital plans of work. So level 3 will need those things, and it will obviously need tools that take those things seriously. And beyond level 3, which I see is will also need to be, and it may be part of level 3, is open semantic models. We've done demonstrations for the Environment Agency where we answered a question, how many days frost did this structure suffer in the last year? Many data sets brought together and giving an answer almost instantaneously. But ultimately, I would say level 3 is removing this choice at the moment we have between printing and submitting. I think the submittal of information will dominate over the print command, and that will be the main characteristic of level 3. And I think that's probably where I need to stop.
Quite a few questions were asked prior to the session, which have all been covered.
Okay, well, I think they have. I hope they have.
Yes.
So for any new ones, okay.
Yeah.
So any other questions?
Yeah, we've had a couple come in. With IFC being essentially file-based information, either XML, COBie spreadsheets, and so on. What is the best way to house that data in a centralized database, and what is the best file format to share information? This person saying we've had issues reading IFC files as it doesn't always keep all the information.
Okay, let's take the second bit first.
Sure.
The implementation, well, IFC is dependent on the quality of the export and the quality of the import functionality that vendors provide. And over the years we have tightened, well, BuildingSMART has tightened the criteria and so on. But the other part of it is that if people have a disappointing experience from IFC, the only people who can fix it are either the exporting vendor or the importing vendor.
Right.
And there are a lot of viewers that you can download to find out whether the information really is in there. And if it isn't in there, then it's the fault of the export. And if it is in there, then it's the fault of the import you're using.
Sure.
And it's actually a matter of driving the vendors to answer that.
Right, okay.
IFC is not necessarily a file-based format. Obviously that's the way it's used at the moment, because although we're trying to move from documents to data, we're still somewhat hamstrung by the fact that we are using files as transfer. IFC can exist within database, and there are protocols and standard APIs for getting information in and out, and that will be the next wave. There are model servers. In Norway they make extensive use of EPM Jotny. In Sweden and Finland they have share a project. There are a number of tools that will do that for you. There's a free one called BIM Server,
right.
And that's the way forward. Undoubtedly, it will. I'm sure level 3 will not be entirely transacted using files.
Sure. And when did you say level 3 was coming? When did you say level 3 was? When are they looking to do that by? Did you say?
Well, I would be happy to do a level 3 demonstration tomorrow. I have the tools on my computer.
Right, okay.
So those who say it's 10 years away are wrong.
Yeah, sure.
And I think I think in 2 or 3 years' time, there's no reason why we shouldn't see lead contractors organising a projects around level 3 based scenarios and designs.
Brilliant. Okay.
And not necessarily in the UK though.
Sure.
We mustn't assume that UK, having achieved level 2, will get to level 3 first.
Sure.
There are other places in the world one could look. Okay.
Okay, fantastic. Another question is coming as well. What data types is most important to share with other business systems?
Okay. Well, on the diagram I showed with the 3 aspects of BIM on it,
yeah.
At the highest level, you've got the site, the facility, and the project. Most external business systems will manage the facility at the level of a zone or a system or a work package.
Sure.
But increasingly, as we share information and cross-link it,
yeah.
The people will get involved with sharing individual component information, individual spaces, individual tasks.
Sure.
It's a matter of progression.
Sure. Okay, fantastic. I think, Tim, I know you've asked a couple of questions earlier on today. I think they've all been covered. If there are any other questions, please don't hesitate to put them across in the chat box now. Failing that, Nick, you've got a couple of numbers and your email address there. What's your preference? What's best way for people to get in contact with you?
If you've got interesting questions, feel free to email them to nn@aac3.com.
If you have any questions for me at all, or would like to understand how my teams and I can help either you personally into your next ideal opportunity, or help recruit within your team for BIM experts, please do not hesitate to schedule a call via my online diary, which is up on the screen now. The address is bimrec.com/diary. Booking for a 15-minute call and we can see whether we can help. That said, thanks everybody. Until next time, I shall see you all soon. Take care now. Bye-bye.